Okay, let's start. Let's start. Write down topic. Write down topic. Equilibrium of a light frameworks. Equilibrium of a light framework. Equilibrium of a light framework. Equilibrium of a light framework. Okay. So definitely for your applied paper, question number 15, part B. Question number 15, part B will be light framework question. Very simple question. Okay, very simple question. So within few minutes you can complete the question. Approximately 9 out of 100 marks will be you can get. Okay, for applied mathematics maximum 9 you can earn for this part. Okay, now we have identified a system of rods. Okay, see this and all. Previously we have analyzed system of rods. They are not light rod, they are weighted rod. So under jointed rod system we have analyzed that. No? Now this is about light frameworks. Light frameworks. Then here we consider all the rods are light. All the rods are light. So if the rod is light, then we can appear only stresses. There are two types of stresses. One is tension, the other one is thrust. Then here we're going to find those type of stresses. So especially we have graphical method. That graphical method we call Bose notation. So we need to analyze that. Okay, very simple thing. Okay, just write down. A framework is a system of rods. A framework is a system of rods where all the rods are light. All the rods are light or negligible weights. And the rods are connected at their ends. Smoothly. Rods are connected at their ends smoothly. Okay. Now you sketch few frameworks. Here see. Here a framework. Rods are connected at the ends. All are light rods. It looks like a bridge, no? It looks like a bridge. Here one framework. So these are light rods. So they are connected at their ends. Okay? So sketch with me. Just sketch with me. Here another one. Here another framework that is connected to a vertical wall. Just sketch. Let's sketch another one. Here another framework. $100 Newton. Here another framework. Just sketch them. Those are we call frameworks. So here special property, all are light rods. All are light rods. So they are connected at their ends. Then we call they are frameworks. Frameworks. Here this is a support, okay? We call fixed support. Here this notation represent hinge. Hinge. So if it look like this, here movable support. It's like a wheelchair. So it has wheel. It can move horizontal plane. Movable support, fixed support, here hinge. Okay. Now with star mark write down. With star mark write down. All the above constructions are rigid. 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 Then the rigid body is in equilibrium. Then the rigid body is in equilibrium. The rigid body is in equilibrium. Therefore, for one rod, or for a section, or for a section, or a vertex, is in equilibrium. Is in equilibrium. That means no resultant force and no moment. No resultant force and no moment. Okay. Now with star mark write down. Another one specialty of this system. All the forces are given at their ends. All the forces are given at their ends. at the ends. Next star mark. A stress will appear in the rod. A stress will appear in the rod. Okay, here rod in tension. Here rod in thrust. So here stresses. So here we call tension, here we call thrust. Okay, just label them. So if you see this type of force, say it is tension. If you see this type of force, say it is thrust. Tension and thrust. Okay. With another star mark, write down. To find stresses, we may consider equilibrium of a vertex. Okay. Now you do with me. Here 60 degree. Here that is on two supports. Here 500 Newton given. Here this framework ABC. Here framework ABC, 500 Newton given here. Okay, then you just mark all forces now. Now here there are two supports now. Then there will be reaction R1, R2 now. Then by symmetry R1 equal to R2. By symmetry R1 equal R2. Okay. Now here consider full system now. Vertical forces R1 plus R2. R1 plus R2 equal 500. Now it is in equilibrium now. Then R1, R2 same. R1 500. Then R1 equal 250 Newton. R2 equal 250 Newton. R1, R2 250 Newton. About 250 now. So now you consider one vertex. Here vertically upward R1 force now. Then to cancel that one we need vertically downwards force. So that can give by this stress. So you mark tension T1, thrust T1 this way. Then horizontal component, to cancel that you mark T2. Symmetrical, then this also T1 no? T1. Then you consider one vertex B. Then consider vertex B. Now the system is in equilibrium, no? The system is in equilibrium. When you consider vertical forces, R1 equal T1 sine 60. T1 sine 60. Then vertical upward forces equal vertical downward force. 250 T1 sine 60 root 3 over 2. Then T1 equal 500 over root 3 newtons. 500 over root 3 newtons. Okay, likewise, we can consider equilibrium condition. Then we can find all the forces. Now here, resolve horizontally. Vertex B, resolve horizontally. T2 equal T1 cos 60. T1 cos 60. Okay. Then T1 500 over root 3 half 250 over root 3 Newton. Those are the forces, no? Okay, complete it. Complete it. You identify here this is tension, these two thrust. Thrust. Complete. Consider vertex by vertex. You go vertex by vertex and it is in equilibrium, then no resultant, resolve horizontal, resolve vertical and find it. That's it, no? Complete. Okay, then finally we get a table, rod, stress, tension, thrust, or magnitude. Okay. Now, rod by rod, we write them. We have AB rod, AC rod, BC rod. Okay. Then here AB rod thrust T1. T1 500 over root 3. Thrust 500 over root 3. AC rod again thrust 500 over root 3 and AC rod, it is tension, no? This is tension. So it is 250 over root 3. 250 over root 3. Okay, complete it. Complete the table. So here we may need to analyze, we need to identify stresses and magnitude. Magnitude and what is that stress, okay? Okay. So when you find in stresses, you can mark T1, T2 into any direction. Okay. So if you mark T1 opposite, then this will be opposite one. Okay. But you will get negative value. So if it is negative mean, if that is negative mean, so that is opposite, no? Opposite. So no worries, you can mark any direction, no worries, okay? This is one technique. First you mark forces, then you resolve horizontally and vertically, then find it. Okay. Okay, now you do here this one with me. Do this one with me. Previous one symmetrical, now this one not symmetrical. 60 degree, 30 degree. Here 500 Newton, A, B, C. Now two supports. Here reaction mark R1, here reaction you mark R2. So we can find R1, R2, consider full system, take moment about B. I'll take this one A, then here A cos 60, then 500 into, here A cos 60, again cos 60. A cos 60, cos 60. Here you take here A cos 60, again resolve, equal R2 times perpendicular distance is A. 500, no? Half, then R2, 125 Newton. Consider vertical forces R1 plus R2, R1 plus R2 equal 500, then R1 equal 375 Newtons. The previous case we had only equal forces, we got only equal forces. Now this is not symmetrical, then they are different. So you mark here R1 375, do with me, 125 Newtons. Now here this is vertically upward force, no? So then to cancel this vertical upward force, we need vertical downward force that can give using this rod only. Then you mark here this say T1, in opposite direction T1. Then vertical component can cancel 375. Then there will be horizontally this way. Then to cancel you mark here T2 force, T2. Then consider vertex B, vertical forces 375, R1 equal T1 sin 60. R1 375, T1 root 3 over 2, then T1 equal (750) divided by root 3 Newtons, T1. Then resolve horizontally, T2 equal T1 cos 60, 750 over root 3 cos 60 half, 375 divided by root 3 Newtons. Now T1, T2 okay. Then here for vertex C, to cancel this vertical force, we need downward force. You mark here T3. Previously, so we took T1, T2, no, same forces. Now here different. Inclinations are different. No? Okay, then you consider vertex C. Consider vertex C. Vertical upward forces 125. T3 sin 30. T3 sin 30. Okay, now simplify. then T3 equal 250 newtons. 250 newtons. Okay, you just mark all forces and just find it. That's it. Okay. So this is very, very simple type. Complete it. Okay, then you complete the table. AB thrust T1 750 divided by root 3, AC T3 250 and T2 375 divided by root 3. Complete. Okay, let's do another example. Okay, you see this. Here consider this framework. Here floor. Two rods are connected like this. Another horizontal rod, another inclined rod. Here 90, 90. Here 30 degree. Here 45 degree. Here A, B, C, D. Start with me. Here 500 Newton. 500 Newton. This is framework. Now here 500 downward, no? Then to cancel that downward force, when you consider vertex B, so we need upward force, no? Then that upward force can give by this AB rod. You mark this A. Then when you resolve, then it can create upward force. And here T1. Then T1 cos 30, here this A. To cancel that one, we need opposite direction force. Then you mark T2. Then you go to this vertex. Here we have horizontal force this way. To cancel that one, we need opposite direction that can create by this. You mark here T3, T3, then T3 cos 45 cancel T by T2. Then T3 downward force, to cancel that one you need upward force. Then mark T4, T4. They are different forces, okay? They are different forces. Likewise, just mark forces. If you can't identify properly, you just mark it, okay? If you can't identify properly, just mark it. Okay? If you get negative value, that means opposite direction. Positive means our direction is true, no? Correct. Okay. Then go to vertex B. Vertex B. Resolve vertically. Then 500. T1 sin 30. T1 sin 30. T1 half. Then T1 1000 newtons. Then resolve horizontally. T1 cos 30 equal T2. T1 cos 30. Consider only this vertex B. 1000 cos 30 root 3 over 2. 500 root 3. 500 root 3 newtons. That is T2. Continue with me. Do with me. Then go to vertex C. Vertex C. Then you resolve horizontally. T3 cos 45. T3 cos 45 equal T2. One over root 2. T2 500 root 3. Then T3 equal 500 root 6 newtons. Then same vertex resolve vertically. Then T4 equal T3 sin 45. root 6, 1 over root 2, 500 root 3 newtons. Now all the stresses are known. Okay, complete it. Then you fill the table. Rod AB, AC, BC and CD. Then AB thrust. AC thrust. BC tension. CD tension. Then AB T1 1000 Newton. AC T4 500 root 3 Newton. BC T2 500 root 3 na. CD is T3 500 root 6. Okay. Okay, finally you complete the table. Okay, let's do another one only. Okay, you try this. You try. Okay, consider this system. Here 500 Newton, 60 degree, 60 degree, 60 degree, 60 degree, 60 degree, 60 degree. Here there are two supports. Take here A, B, C, D, E. Okay, you try it. Just try. Do alone. Here this is symmetrical system. Here reactions R1, R2, they are same. Then 250 Newton, 250 Newton. Then vertical upward force can cancel by vertical downward force. Mark T1, T1, then horizontally component cancel with this T2. Then here T1 vertical component you cancel by T3 downward. Then T3 cos 60, T1 cos 60 you cancel by T4 here. T4. So if you can think that way, then that's good. Otherwise you just mark it. Then here symmetrical system, then left hand right hand side same. Then you can mark here T2, same T2 value. T2, here T1, here T3. Then you can consider vertex A, vertical force upward 250 equal T1 sin 60. Then T1 equal 500 over root 3 Newton. Then resolve horizontally T2 T1 cos 60. 500 over root 3 half. 250 over root 3. 250 over root 3. Those two okay. Then consider vertex B. Vertically upward forces T3 sin 60, T3 sin 60, 2, 3, 3 sin 60. You consider about that vertex only, yeah? That point only, equal 500. Root 3 over 2, T3 equal 500 over root 3. 500 over root 3. Now we have to find only T4, no? Then consider vertex D. Vertex D, resolve horizontally, T1 cos 60, T3 cos 60, T1 cos 60 equal T4. T1 cos 60 plus T3 cos 60. T1 500 over root 3. T3 500 over root 3. It is 500 over root 3. Then all are positive mean. All marked directions are correct. Tension, trust, tension, trust, tension, trust, tension. No? Then you can fill the table. Complete. Okay, that is one method of finding stresses. Okay. So for some cases, we can't think the direction of stresses. So such case, you better to mark any direction. So if you get negative values, that means the stress will be opposite one. Okay. So here we can easily analyze all, and we can mark whether it is tension or whether it is thrust. Okay. But for some cases, we can't think. Complete. Okay, then you can update the table. Huh? You can update table. Let's do one another. Let's do one another. Okay, here this method we consider about equilibrium of one vertex now. We consider equilibrium of one vertex. Then we can do only resolving, no? Horizontal resolution and vertical resolution we can do only. So we can find only vertex with two unknowns by that case, okay? We can find only vertex with two unknowns. More than two unknowns, difficult. So first you move to two unknown vertex, maximum two unknown, okay? Okay, you start this question. Ninety, 90, here 45, 100 Newton, another 100 Newton, A, B, C, D, E, F. Here a hinge. Okay, start doing it. Take little time. Hundred Newton downward. To cancel that one, you mark here T1. Then to cancel horizontal component, mark T2 here. Then consider vertex C. Upward forces T1 sine 45 equal 100. Then T1 equal 100 root 2. Then resolve horizontally. T1 cos 45 equal T2. It is 100 Newton. Then you go to this vertex D, T2. To cancel this one, mark T3 like this. Then T3 cos 45. T3 cos 45. Go to vertex D. T3 cos 45 equal T2. T2 equal 100. Then T3 100 root 2. Then T3 vertically downward component cancelled by this. T4. Then T4 equal T3 sine 45. Then come to this vertex. Then here T1 vertical downward, T4 vertical downward, in 100 vertical downward, you better mark here upward. Here T5, then consider vertically upward force at vertex B. T5 sine 45 equal 100 plus T4 plus t1 sine 45. t1 sine 45. Okay, then you simplify it. Hundred t4 100 t1 100 root 2. Here 100, then t5 300 root 2 t5. Then here somewhat difficult to identify direction. You just mark it. T6. Then go to vertex B, horizontal component. T6 plus T5 cos 45 equal T1 sin 45. T6 300 T1 100. So we got minus 200. So here minus mean opposite direction. I have marked here thrust, but that is tension now. Okay. Thereafter you go to here this vertex. Here mark T7, then T8. Then go to vertex E, but vertical forces T3 sin 45 equal T8. T3 100 root 2 no? T8 100. Then resolve horizontally. T7 plus T6 equal T3 cos 45. Minus 200 T3 100 root 2 into 1 over root 200. T7 equal 300. Complete. Okay, now here vertex A. Vertex A, I haven't marked full forces here. Vertex A, I haven't marked full forces. Then don't resolve it. Don't resolve it. But if you need to resolve, you mark horizontal vertical component. That's hinge now. Thereafter you can resolve. Okay, mark horizontal and vertical component here and here. Then you have to find them. Thereafter resolve. Okay. Okay, that is just resolving technique. So again we have another technique we call section method. Okay, we have section method. Okay, write down another subtopic, section method to find stresses. 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 Okay, just write there, just write. To find stresses, to find stress, to find stress in a required rod, to find stress in a required rod, section method is used. Section method is used. Section method is used. Okay. In that method, sketch a line to cross, maximum 3 rods. Maximum 3 rods with the required rod. Then each section is in equilibrium. Then by considering resultant force and the moment, by considering the resultant force and the moment of each section, unknowns can be obtained. Okay. Now previous technique, we need to go one by one. Okay. We need to go one by one vertex. So at the beginning we have to select with maximum 2 unknowns. Otherwise we can't complete it. So we have to select proper vertex first. Now here this technique somewhat different. Okay, see, I'll do example. See this. Consider this framework. $100 Newton, 60 degree, 90, 60 degree. A, B, C, D, E, F. Okay, now let's say we need to find stress at this vertex, this rod. If you need to find stress in this rod, we do this way. We have to select this one. No? Then you consider 3 rods. So select 3 rods. I'm going to mark here a line to cross these 3 rods with this one. Okay. Maximum 3 rods. You cut maximum 3 rods because we can resolve horizontally, we can resolve vertically, and we can take moment. Now the full system is in equilibrium. Then right hand system in equilibrium, left hand system in equilibrium. Full system is in equilibrium. That means one section also in equilibrium. You sketch a line to cross maximum 3 rods. Then here you mark T1, T1, here T2, here T2. You mark only stresses for these crossing rods. Here T3, T3. Just do up to that. You sketch a line to cross maximum 3 rods. Then here AB, BE and ED will cross now. Then here you mark stresses for each case. No need to think about direction, just mark it. Just mark it, okay? So by this method we can find required rod directly. But previous one we have to go one by one. Here at once we can find required rod. Let's sketch and mark forces here. Now say this. So I'm going to erase one side. I'm going to erase left side now. Okay. Now here this system is in equilibrium. Now this system is in equilibrium. That system is in equilibrium. So you take moment about B. Consider full system, take moment about B. Then here 100 into, here equilateral triangle, no? Take this length A plus T3 into perpendicular distance here A sin 60, no? A sin 60. Now no moment, no? That will be 0. Right hand section in equilibrium. Then you can take moment about B. If we take moment about B, we can forget T1 and T2, no? Then 100 into A, T3 into A sin 60. Then simplify. Then root 3 over 2. Then T3 equal 200 over root 3 minus Newton. Minus mean opposite direction. So I have marked here thrust, no? Now it is not thrust, that is tension. Okay, then you go to full system now. Again, resolve horizontally. T1 plus T3. T1 plus T3 equals 0. No any other horizontal forces. Then T1 equal minus T3. Then 200 over root 3. Then T1, it is thrust now. No worries. Then resolve vertically. Vertically. 100 plus 100 plus T2. 100 plus T2 equals 0. Then T2 equal minus 200. So I have marked here thrust now. Now it is tension now. 200 Newton tension. So by this method, we can easily go to required rod. But previous method, we can't go to required rod at once. Okay. So you cross maximum 3 rods. Maximum 3 rods means maximum 3 unknowns. So we have capacity to resolve horizontally, resolve vertically, and take in moment. We have 3 options. That's why we cut only 3 rods. Then if we cut 3 rods, we have 3 unknowns, we have 3 options, we can find them. Okay. Then if you need to find here this tension or thrust here by these two, again you cross, take another line to cross 3 rods again, and again go, complete it. Okay, you find them, find it. Okay, then here minus mean T3 tension, T2 minus mean T2 tension, na? Other one thrust, okay. Okay, let's do one only. Let's do another one only. Okay, sketch this. Newton, 200 Newton. Here two supports. Two supports. A, B, C, D, E, 60 degree, 60 degree, 60 degree, 60 degree, 60 degree, 60 degree. Okay, then here you find here reactions. Mark R1, mark R2. Without finding this reaction, we can't go, somewhat difficult to proceed, okay? Now, consider moment about A clockwise, then 100 into, you take here A, 200 into another A, 3A, R2 into 4A. Then R2 equal 700 over 4. 700 over 4. Here we can simplify now. 350 over 2, 175. No? 175 newtons. That is R2. 175 newtons. So let's say we need to find stress at this rod AB. Let's say we need to find stress at AB. Then you sketch a line to cross 3 rod, maximum 3 rod with that. Then mark T1, T1, here mark T2, T2, T3, T3. Now we know R2, no? Then by vertical forces, R1 plus R2 equal 300. Then R1 equal 125 Newton. 125 Newton. Okay, you sketch line to cross 3 rods with AB. So let's say we need to find stress in AB rod. Then you can remove one section. You can consider only left section or right section. Whatever it is, okay. You consider one section. Okay. So thereafter you find T1, T2 and T3. Okay, start now. Do up to that and start. Okay, then you consider left hand side. Consider left hand side. I'll erase this. I'll erase right hand side. Now here this section in equilibrium. This section in equilibrium. Now here are the forces. You resolve vertically 125, T2 sin 60 equal 100. Then T2 minus 25 minus 50 over root 3. Then T2, not thrust, it is tension now. Minus 50 over root 3. Then you take moment about E vertex. So if you take moment about E, then we can remove many forces here. Then we have T1 and R1. 125. Here all are opposite direction. 125 into, take here A cos 60, perpendicular distance A cos 60. Then T1 A sin 60, 0. Then T1 equal minus 125 over root 3. Then T1 also, not thrust, it is tension now. Then resolve horizontally. T1 plus T3 plus T2 cos 60. It is 0. T1 minus 125 over root 3. T3, T2 minus 50, over root 3 cos 60 half 0. Then here T3, here 25 150 over root 3. That is T3 value. That is T3 value. Likewise, we can find required rod easily by this section method. Okay, now we have done two methods. But the special one is Bose notation. Special one is Bose notation, that is graphical method. Huh? So we need to do our A-level correction using Bose notation. Write down subtopic Bose notation. Bose notation, B-O-W-S. Bose notation. Okay, right there. Bose notation is a graphical method. Bose notation is a graphical method to find stresses. Bose notation is a graphical method to find stresses. Here, force polygon can be sketched. Here, a force polygon can be sketched by considering forces at a vertex. Okay, now see this. Now see this one. Now you consider, so we have technique, but before that, you think this one. So here, at this vertex, there are three forces. Say F1, F2, F3. So if the particle is in equilibrium mean no resultant, no? If the particle is in equilibrium mean no resultant. Then here we can sketch force triangle, no? Can sketch force triangle here the way. So mark F1 like this. At the end point you mark F2. At the end point you mark F3. Then here we see cross diagram. Here this is cross diagram. If the system is in equilibrium, no resultant force. No resultant means here we say It is cross diagram, cross polygon. For here, especially triangle. First triangle. Okay. Then here first triangle. We're gonna use that technique. Let's see another one. You consider another vertex like this. Here F1, here F2, here F3, here F4. If this particle is in equilibrium, no resultant. No resultant means here we can sketch first polygon. So we have 4 forces now. We have 4 forces there. Then first sketch F1. Sketch F1. At the end point, you sketch F2. At the end point, you sketch F3. And at the end point, you sketch F4. Then here must be closed one. Here first polygon. First polygon. Here first triangle. So if the vertex is in equilibrium, we can sketch first polygon. So by Bose notation, we are going to do same thing, but different steps. Same thing with different steps. Okay, just sketch them. Here no resultant. Particle is in equilibrium. So here there can be many forces. There can be many forces, 2 forces, 3 forces, 5 forces, whatever it is, okay. Sketch them. Okay. Now see this one. Here this case, we can sketch first polygon because we know all the forces. We can sketch first polygon because we know all the forces, no? But in our case, we don't know all forces. We have to find them, no? We have to find them. Then partially we know some forces. We know some forces partially. Then we have to find them. We have to sketch the force. Okay, write down. To sketch first polygon, by Bose notation. To sketch first polygon by Bose notation, consider the following steps. Consider the following steps. Consider the following steps. Step number one. Step number one. Step number one. Mark a boundary line. Mark a boundary line around framework. Mark a boundary line around framework. And produce all external forces to cut it. And produce all the external forces to cut it. Okay, under that write down, under that another point write down, under that. Produce external force. Produce external forces into one direction only. Into one direction only. Second, don't produce a force to cut a rod. Don't produce a force to cut a rod. Okay. Okay, now see this. That is first point. No? First point. First point එකට කලින් තව point එකක් තියෙනවා. ඒක මට දෙන්න අමතකුණා. First point එකට කලින් තව එක point එකක් තියෙනවා. ඒක ලියා ගන්න එතන පොඩි space එකක් තියෙනවනේ. Mark all external forces and find if it is necessary. Okay, before that point you write mark all the external forces and find if it is necessary. Mark all the external forces and find if it is necessary. That must be first point. Mark all the external forces and find if it is necessary. Okay, second point, that one, previous one. Second point, mark boundary line and produce external forces to cut it. Okay, so later we will see how to do that. Okay, go to third step. Select one vertex. And go around it. Region to region. Go around region to region. And sketch first polygon. Sketch first polygon. ඒකට කලින් තව එකක් තියෙනවා. ඒක තමයි කියනවා. ඒකට කලින් පොඩි ලයින් එකක් දාගන්න. Label the regions. Label the regions. Label the regions by simple A, B, C, put some dots. Simple A, B, C, put some dots. Okay. Okay. Now see. Step number one. Step number one. Mark all the external forces and find if it is necessary. Step 2, mark a boundary line around the framework and produce all the external forces to cut it. Okay. Next step, label the regions by simple A, B, C, D, so on. Label the regions. And fourth one I have given, no? Fourth one, by considering a vertex and go around it and sketch force polygon. Sketch force polygon. Okay, under that write down, කොකට ලයින් එකකට තියාගෙන. Okay, under that write down. නෑ දැන් හරි. Better to select a vertex with minimum number of forces. Better to select a vertex with minimum number of forces and maximum of them are known. Better to select a vertex with minimum number of forces and maximum of them are known. Maximum of them are known. Maximum of them are known. Okay, under that again write down. A vertex with two unknown forces. A vertex with two unknown forces. A vertex with two unknown forces must be selected. Must be selected. Okay, now see this technique and this method. So this is very simple method, but you have to practice it. You have to practice it. See clearly. Here this is simple question. 60 degree. Here two supports. Here 500 Newton. A, B, C. Then first step, mark all the external forces. Here two supports, no? Then there will be reactions. Symmetrical system, no? Then R1, R2 both are same, 250, no? This is first method, first step. That is very simple. Mark all external forces and find if it is necessary. So I'll describe what is if it is necessary thing. But don't worry, you mark all the forces, you can find everything. No? Now sketch a boundary line. Here boundary line around the framework and produce external forces. Here produce to cut this boundary into one direction. Here you can produce upward or downward, but it is okay. But you consider only one direction to cut only boundary, okay? But if you consider this force, if you produce this, say, that cut this rod, no? Don't do that. So you produce other direction. So I told you, when you are producing, don't cut boundary. Now here label A, B, C, D. Okay, very simple thing. So A, B, C, D order, you can mark whatever it is, okay. Then no order, you can mark A, B, C, D, no issue. So usually you consider vertices, capital letters, regions by simple letters. Okay, do up to that, do up to that. Now when you analyze this, so we have vertex A, B, C, no? Here rod mean a force, no? We have stress. In the rod we have force, stress, no? So here force, 3 forces at this vertex, 1, 2, 3 forces, 1 known, 2 unknowns. Here when you consider this vertex, 1, 2, 3 forces, 2 unknown, 1 known, no? When you consider here 1, 2, 3, vertex A, we have 3 forces, 1 known, 2 unknowns. So I told you one important step, we better to select vertex with minimum number of forces and maximum are known. Then all are similar, no? 3 forces, 1 known. And another point I told you, that is, you better to select a vertex with 2 unknowns. Then you can select this one or this one, whatever it is, okay. Okay. Now see, now we need to sketch first polygon. Now practice this very carefully. You select one vertex. I'll select this. Okay. See carefully. You select this vertex, then go around it. Go around it. Until you complete the section, you go only one sense. Until you complete the section, go only one sense. So if you select this vertex, go anti-clockwise sense. Then you go to this vertex and go anti-clockwise. Then you can go to this vertex and go anti-clockwise. Until you complete the section, go only one sense. A levels ඉවර වෙනකම් එක sense එකක් ගත්තත් කමක් නැහැ. ඕක මාරුනොත් මාරු වෙනවා. එහෙනම් එකක් විතරක් practice කරන්න. Okay, select this vertex. Cross this one. A to B, upward 250 force, no? Upward 250 force. You mark it. See carefully. A to B, upward. Then you mark A here, B here. Then when you move A to B, that moves upward, no? Yeah, upward force. Then B to D, it is horizontal one. B to D, horizontal one. We know B. You sketch horizontal line here. So on this line there will be D. We don't know exactly magnitude and direction. Then go to DA. AB, B, D, DA. Here 60 inclination to the horizontal. Here A is 60 inclination to the horizontal. So in this on this line there will be D. So previously we got D on this line. Now we got D on this line. Then here this will be, common point will be D. Common point will be D. Then go to other vertex. Again cross known one, BC upward 250. Here B no? C upward 250, BC. CD, here sketch this. So we know D, we can sketch diagram. This is first polygon. That is first polygon, okay? Okay, now start doing. You practice alone. Take time. If you have doubt, do with me. Select one vertex, put finger, and cross known one, A to B, upward 250. Ne? A to B, upward 250. Sketch it. Here A to B now upward. Then AB length will be 250. Do with me. A to B 250. Then B to D horizontal line. Here B to D. B is here. Now sketch horizontal line. Then D on this line. Further move. D to A to the horizontal 60. We know A to the horizontal 60 line sketch. Then intersection point, common point you mark D. Here 60-degree inclination. Okay. Then go to other vertex. Again go same sense. B to C upward 250. B to C upward 250. CD to the horizontal 60. Here to the horizontal 60. This is first polygon. Okay, now see very carefully. Select vertex again. Don't do it with your mind, okay? You put finger here and go around it. Then again go around BD, B to D. Then B to D, you go to this diagram. This is stretch diagram. Then B is here, D is here. You go B to D. You have to move this way, no? B to D. Then you have selected one vertex. So you put arrow. B to D, move in direction, arrow you put. Then go to DA. D is here, A is here. DA, here the direction. You mark that direction to the selected vertex. Then other corners you mark opposite direction. Okay, do up to that. Do alone, huh? B to D, here this way, you mark arrow there. DA, here this way, you mark arrow. Then go to this vertex again, go same sense, C to D, here this way, C to D, mark it, then opposite direction at the other vertex. Now we can clearly see tension, trust, trust. No? Tension, trust, trust. Do up to that. Okay, see how to mark stresses again. Huh? See how to mark stresses again. Here this is stress diagram. You select one vertex again. You go same sense. You go same sense. B to D, B to D. Here B to D, here the direction, moving direction. You mark same direction, arrow here. DA, here DA, here this direction. You mark arrow. Then other corners, opposite direction. Then go to this vertex, CD, you have to move same sense. Huh? CD, here this way, you mark arrow here. Then identify tension, trust, trust. Okay. Then complete the table, rod, stress, tension, trust, magnitude. Do with me. So we have three rods, AB, AC, BC. BC. Then AB, AC, trust, no? AB, AC, trust. BC, tension. Now see very carefully. AB, AC, trust, and here tension. See the sun all. Now AB rod, see the sun. AB rod, AB separated by AD regions, no? AB rod separated by AD region. Therefore, AB magnitude represented by AD. See it clearly. AB rod separated by AD, then by AD that represent AB thrust or AB thrust. Then BC separated by BD, then BC given by BD regions. Then AC separated by DC, then that given by DC. Okay. Then magnitude mean length of these line segments. Okay, now see, further see. Now you know here, this is AB mean 250. Here 250. Here 60-degree inclination. You know geometry now? Then find these two lengths. AD, apply sine rule. 250 AB over sine 60 equal AD over sine 90 equal BD over sine 30. BD over sine 30, that's it. Then AB mean 250 sine 60 root 3 over 2 sine 91 sine 30 half. Then by this you find AD. AD equal 500 over root 3. BD equal 250 over root 3. Okay, then you update the table. AD 500 over root 3. BD 250 over root 3. Then DC. Then DC equal with AD, no? AD, DC same according to geometry. Then here 500 over root 3. Likewise, you complete the table. Fill the table. Okay, now complete it. Okay, let's sketch 2-3 diagrams. Let's sketch 2-3 diagram. Okay, check this, huh? Do with me. Do with me. Here 60 degree, 30 degree, 500. Here two supports. R1, R2. R1, R2. Do with me. Mark boundary line, produce forces to cut it. Label regions A, B, C, D. A, B, C, D. Do up to that. Okay. Sketch soon. Now see this. Here three forces we haven't, we don't know R1 and R2, no? Then all three forces unknown. But when you go to here, 1, 2, 3 forces, 2 unknown. Then you better to select here this vertex, no? You better to select 2 unknown forces with 2 unknown. Vertex with 2 unknowns. Okay, now select this vertex, go around it. CA downward 500. CA 500. Do with me. Then AD to the horizontal 60. AD to the horizontal 60. Then DC to the horizontal 30 this way. 30. Then this will be common D point. Then go to another vertex. Here AB, B on this line, BD horizontal, D is here, then B is here. Then here, first polygon. That's how we sketch. Huh? Do alone. First go to here, go around it. Then move to another vertex and go around it. When all the regions here, then it is completely done. Practice, huh? Try alone, practice. Okay, same time mark forces, select vertex now, BD, here B to D, DA, here D to A. Then other corners, opposite direction. Then go to next vertex, go around it, CD, here CD, CD. Tension, trust, trust. Okay, that's enough for light rod systems for today.